Hello everyone, I welcome you all to Startup Academy. This academy is exclusively for ISS, and we have been covering the topics sampling techniques, in which in the previous lecture we did ratio estimator and double sampling. We started with that. We found out the bias of ratio estimator and what are the results regarding this. And today we will do mean squared error of ratio estimator and double sampling only. First of all, let us recall what we did, yes, in the previous lecture. That was bias of ratio estimator and double sampling. Bias of ratio estimator in double sampling came out as 1 upon small n dash n prime rho cx cx minus rho cy. This was the bias that came out in the previous lecture. So now we know that if n is very large means n is almost equal to infinite. When n is infinite, then our bias of this estimator, ratio estimator in double sampling, becomes negligible, or we can show this like that. If n is equals to infinity, then y cap r d, which is ratio estimator or in double sampling, is becomes 1 upon infinity, k upon infinity, where k is the rest of the terms, which is nothing but 0. And hence this is the case of bias estimator. And if cx minus rho y is equals to 0, then this line pass cx is equals to cy, or we can say cx square is equals to cx cy, or cx is equals to cy. Then this this regression line passes from origin. These were the two results that we did in the previous lecture. I hope you are clear with all of them. Now today we'll start with MSC, which is mean squared error. MSE of ratio estimator in double sampling. Right? So mean square error is nothing but variance, the error term in the variance. So this can be written as mean square error of ratio estimator in double sampling is equals to estimation of mean of ratio estimator in double sampling minus y bar whole square. Now this term can be taken from the previous term that we did yesterday, y bar rd minus y bar, which is nothing but epsilon epsilon naught plus epsilon 2 minus epsilon 1 plus epsilon naught epsilon 2 minus epsilon naught epsilon 1 minus epsilon 1 epsilon 2 plus epsilon 1 whole square. This was the case of y bar rd minus y bar. So now we will take here approximation up to order 2. We have to take up to order 2. So if we take the squares of this two terms, these will become more than 2, which is 4. So all these power which are raised with 2, we remove them and we are left with estimation of epsilon naught plus epsilon 2 minus epsilon 1. You can check it after multiplying, after squaring the terms. It will always be greater than 2. So we have removed all those values from the estimation. That will afterwards will also be removed. So estimation of epsilon naught plus epsilon 2 minus epsilon 1 whole square is epsilon naught square plus epsilon 1 square plus epsilon 2 square plus epsilon naught epsilon 2 minus epsilon naught epsilon 1 minus epsilon 1 epsilon 2. This will be the square. Now we know that estimation of epsilon, what were epsilon naught? Epsilon naught was y bar minus capital Y bar upon capital Y bar. Epsilon 1 was x bar minus capital X bar upon capital X bar, and epsilon 2 was x bar prime minus capital X bar upon capital X bar. These were the values. So estimation of epsilon naught, as we did in yesterday's class, it is nothing but 1 upon n minus 1 upon capital N bracket sy square upon y bar square, which is nothing but 1 upon n minus 1 upon capital N cy square. Estimation of epsilon 1 square is equals to 1 upon n minus 1 upon capital N sx square upon x bar square, which is 1 upon n minus 1 upon capital N cx square. Estimation of epsilon 2 square is 1 upon n dash minus 1 upon n sx square upon x bar square, which is nothing but 1 upon n dash minus 1 upon n into cx square. This will be capital N only. Then estimation of epsilon naught epsilon 2 was covariance y bar and x bar prime. Thus covariance can be written as covariance of estimation of y bar given n prime and estimation of x bar prime given n prime plus covariance of estimation of covariance of y bar and x bar prime given n prime. Which is nothing but covariance between y bar and capital X bar. These two are not random variables, so hence their covariance is 0. And plus we get covariance of y bar and x bar, which comes out to be 1 upon n prime minus 1 upon capital N sxy upon xy y bar, x bar y bar. Now we know that rho is equals to sxy upon sxsy, which is nothing but 1 upon n prime minus 1 upon capital N sxsy rho x bar y bar. And opening this, we will get estimation of epsilon naught and epsilon 2 equals to 1 upon n prime minus 1 upon capital N into rho cx cy. Now estimation of epsilon naught and epsilon 1, which is nothing but covariance between y bar and x bar. Here it is prime. It will be 1 upon n minus 1 upon capital N, similar to this rho cx cy, because this is the covariance between the second phase and the first row, x bar and y bar. So we will take the sample n, which is from the second phase. Now last one is estimation between epsilon 1 and epsilon 2, which is nothing but estimation between x bar minus capital X bar into x bar prime minus capital X bar upon x bar whole square, which comes out to be 1 upon x bar whole square estimation 1 to estimation 2 of x bar minus capital X bar x bar prime minus capital X bar given n prime. Now this becomes, given n prime is nothing but this conditional will become uh, like this, estimation 1, this will be x bar minus capital X bar whole square, which is nothing but 1 upon capital X bar square into sx square upon into 1 upon n prime upon capital N, which is nothing but 1 upon n prime minus 1 upon capital N cx square. So these are the derivations. Now we'll put the values here. MSE, mean squared error of ratio estimator in double sampling, is given by estimation of epsilon naught square plus estimation of epsilon 1 square plus estimation of epsilon 2 square minus estimation of epsilon naught epsilon 1 minus estimation of plus estimation of epsilon naught epsilon 2 minus estimation of epsilon naught epsilon 1 epsilon 2. This was the formula. The estimation of epsilon naught square is nothing but this 1 upon n upon capital N cx square. Epsilon 1 square would be okay. Epsilon naught was cy square and epsilon 1 is cx square. This was cy square and this is 1 upon n minus 1 upon capital N cx square. Then the next one was 1 upon n prime minus 1 upon capital N C x square. This one. And now estimation of epsilon naught epsilon 2 would be this n prime minus capital N would be 1 upon n minus 1 upon capital N rho cx cy naught and 2 would be 1 upon n prime minus 1 upon capital N into rho cx cy, and 1 and 2 would be minus 1 upon n prime minus 1 upon capital N to cx square. As we can see here, this is e naught e1 is 1 upon n minus 1 upon capital N rho cx cy, and e1 and e2 is 1 upon n prime minus 1 upon capital N cx square. Okay, so now we'll solve all of them. On solving, we will get 1 upon n minus, taking the common terms of this coefficient 1 upon n and 1 upon capital N, we will get cx square plus cy square. This, and this minus rho cx cy. Then the second term would be the coefficient with 1 upon n prime minus 1 upon capital N. This would be, okay, so here we haven't taken 2. These all will be multiplied by 2 because we are taking the square. So here also all of them will be multiplied by 2. So this would be minus 2 plus 2 minus 2. So here it also comes to, and we'll take cx square minus 2cx square plus 2 plus 2 rho cx cy. Cx square minus 2 is MSE of ratio estimator in double sampling would be 1 upon n minus 1 upon capital N cx square plus cy square minus 2 rho cx cy, and this would be plus 1 upon n prime minus 1 upon capital N 2 rho cx cy minus cx square. Now this is ratio estimator of single sampling, which we did before, and this is another term. So if we can write it as MSE of ratio estimator in double sampling is equals to MSE of ratio estimator in single sampling, which we denote it as R only, plus 1 upon n dash minus 1 upon capital N into 2 rho Cx Cy minus Cx square, which can be written as MSE of ratio estimator in double sampling minus MSE of ratio estimator in single sampling is equals to 1 upon n prime minus 1 upon capital N 2 rho Cx Cy minus Cx square, right? So if this is greater than 0, if 2 rho Cx Cy is minus Cx square is greater than 0, then we will say that rho is greater than 1 upon 2 Cx upon Cy. Then ratio estimator of single sampling is more efficient. If otherwise the case is rho is less than 1 by 2 Cx Cy upon Cy, then we can say that ratio estimator for double sampling is more efficient. And if rho is equals to this, both are equally efficient. So this completes your mean squared error of ratio estimator in double sampling. I hope that you got all that we have done today in the class. Keep on revising the syllabus again and again, and keep on watching the lecture video continuously, because only that you will be able to understand, and only that we'll be able to and by following that we'll be able to prepare till June. All the best. Thank you.